Today we are going to discuss classification of polymer on the base of chain arrangement, on the base of chain structure, that how the polymer chain arranged with respect to each other. You know that polymer is actually composed of monomer, clear? And when these monomer, for example, if we write here is, for example, this is A and this is B and this is C and D and so on. So you know that the polymer is actually composed of monomer. When monomer attach with each other, they form a long chain, clear? So this chain may arranged linearly, as clear? So when the polymer chain arranged with respect to each other linearly, then such polymer are known as linear chain polymer, clear? What? Linear chain polymer. They have, for example, polyethylene, clear? So the polyethylene chain can arrange each other linearly, clear? So linear chain polymer are those polymer where the long chain of polymers are arranged what? Linearly, just like parallel, clear? So they have so many property, like they have density very high, their density is very high, their density is a very high, they have a high tensile strength, they have a high tensile strength, clear? They have a high melting point, clear? So these are some properties of linear chain polymer, clear? So melting point of these are very high, so each was some basic property. Their density are high because they are well packed. Kya? Well packed polymers, clear? Here the polymer chain arranged with respect to each other with very good manner, clear? So again we are going toward the next arrangement, that is branched chain polymer. What? The second is branched chain polymer. The second one is branched chain polymer. So the polymer chain can also arrange each other with what way? With branched way. For example, this is a long chain, clear? And this is also a long chain, and this is also a long chain, and this is also just like a chain, clear? So here the first one, if there is such type of branches, clear? Easy. So here there is a main skeleton, and you can see some branches here. So such type of branched polymer are known as short chain polymer, short chain branched polymer, short chain branched polymer, या short branched polymer, clear? As the name indicate, what? Short branched polymer, clear? Here you can see here, if there is a polymer, clear? For example, here is a polymer, this is a backbone, actually this is a backbone, and you can see these are some branches, clear? You can see these are some branches, and the length of the branch is more, clear, very high. So such type of polymer which are actually branched in nature. These are also branched. These all are branched in nature, but here the chain are short. But you can see here, this is a main skeleton, while the branches chain are longer. So these are known as long branched chain polymer. Long branched chain polymer. Clear? There is another type of polymer, for example, this. Clear? So these are known as hyper branched chain polymer. Hyper branched chain polymer. Clear? So branched chain polymer. So branched chain polymer are those polymer where one chain work as a backbone and there is small other projection from this main skeleton. For example, here this is a main skeleton and you see this is a branches. Clear? So this is known as short branched polymer. This is another polymer which are actually branched in nature. Here the length of the branch is long. So such type of polymer is known as long branched polymer. This is another type where these are the main skeleton and here is a branches which have more branches or which divide further in branches. So such type of branched polymer are known as hyper branched polymer. And such type of branches you can see here is a center and there is it is just like a branches. Clear? So it is known as stars. What? Star is it is actually just like a star. So it is known as stars branched polymer. Clear? Stars, it is actually just like a star. So polymer chain can be arranged as and as. Clear? So for example, the example of branched polymer is what? Is starch. Is what? Is starch or amylopectin. Actually amylopectin and glycogen. Clear? You can see the structure of the glycogen or amylopectin where there is glucose arranged with different way, in branch way and also with linear way. Clear? If you see the structure of cellulose where the glucose arranged linearly, what? In linear manner, where the glucose structure or where the glucose polymer chain arranged just like linearly. Clear? But in starch form or amylopectin form or in glycogen form, the glucose chain are just like branched. Clear? So these branch can be such short chain, long chain, hyper and also in a star form. Clear? So the next is cross linked form. Cross linked polymer. What? Cross linked polymer or polymer network polymer. Clear? The third one is cross linked polymer. Clear? So here the word indicates cross link. Here there should be some cross linking. The cross linking nature will be covalent bond. As in the previous lecture we have shown the cross linking for bakelite. We have shown this cross linking for bakelite. You can confirm this cross linking from our previous videos. So here the cross linking may be as, for example, this is one chain and this is a second chain and these chains are arranged with each other or bonded with each other by cross linking. clear, by cross linking. Some, clear, what is this? Cross link. These are actually cross link. What? Cross links, clear. And then what type of bond it is? It is actually covalent bond. It is actually covalent bond, clear. They may be interpenetrating, they may be inter so okay, so they may be interpenetrating as, for example, these are a type of one, that is cross-linked polymer. If other chain are arranged as, for example, say here interpenetrating, this is actually for just like we can say simply cross link or penetrating only. So for interpenetrating we can write it as interpenetrating. Inter means inside, penetrating means to pass from their body, clear. So if we write another chain as which go inside the former chain, so such type of polymer is known as interpenetrating, clear. There are some semi penetrating also. Semi penetrating means semi penetrating, this is just like cross linked, clear. These are cross linked, and if there exists some linear chain, clear, so we call it semi penetrating, clear. So we have discussed what? We have discussed number one, linear chain polymer. So the linear chain polymer, example of linear chain polymer is polyethylene, clear. Polyethylene, which have high density, high tensile strength, clear, and high melting point also. And they where in the what, in linear chain polymer, the polymer arranged linearly with respect to each other. So in branched chain polymer, the polymer are arranged in such a way that they have one backbone and other branches, clear. So the branches may be short, may be long, may be hyper. The branches may have sub branches, and also they can arrange in a star form. Example is what? Example is just like starch, amylopectin or glycogen, clear, which have low density, low tensile strength, clear, as compared to and low melting point as compared to what? As compared to linear chain polymer. The other one is cross-linked polymer. Cross-linked polymer means where the polymer chain form a cross-linking, where the polymer chain form cross-linking with each other, and this cross-link is actually a covalent bond. Due to this cross-linking, they become very tough, very hard, clear, and very its tensile strength or its rigidity is very high, and we cannot guess the melting point for such polymer which have cross link, because on heating it become more and more hard, clear, more hard, and we cannot melt them, clear. So if we increase the heat for them, they will degrade, not melt, clear. So this was about the classification of polymer on the base of what? On the base of polymer chain arrangement. So note down and learn it.